Hey everybody, welcome to this gnarly lesson time where I want to talk about reflections, which is a really cool feature in the Dremio Lakehouse platform. But to really appreciate how cool it is, let's just talk about what you would do without it. And again, in this video, I want to focus on one type of reflection called a raw reflection, which is going to be most analogous to a materialized view. Now, how would a materialized view typically be used? You have a very large table and running full scans on that table to conduct different and applying different filters to that table just tend to, well, be very time consuming, okay, and not efficient for your analyst. So oftentimes what you do is you'll materialize, meaning make a physical copy of certain sort of intermediate result sets. So in this case, imagine here we have a voters table that represents all the voters in the country. I might want to create a materialized view of all the voters in New York. So that way, if I run queries for specific to New York elections, those queries will be faster because I'm only querying among the New York result set. The problem is this now ends up creating several different namespaces. So now I have, voters underscore New York, voters underscore Ohio, and then there might be other materialized views from there. So now as the analyst, I have to keep track of all these different namespaces to know exactly what is the right thing to query to get the right performance for my particular query, for my particular ask. Wouldn't it be easier if everyone could just kind of query the main table, or if you just had less views that had to be materialized? Well, this is where reflection comes in. Well, reflections fundamentally does a very similar thing where it materializes the result set of that particular view, but it does a couple things a little bit differently. One, it doesn't create a new namespace. So essentially what's going to happen is that when a query comes in for that particular table or view or any descendants of that table or view, okay, which is another really cool benefit, what's going to happen is that Dremio will intelligently determine whether a particular reflection that exists would accelerate that query. So it's going to basically figure that out and just swap it out, either the entire reflection or a portion of that reflection to satisfy the entire or portion of that query, whatever it can do to get the fastest query possible. Okay, so it's really intelligent in how it handles it. It's not just a straight swap, okay, and it isn't based on the name that you query. 2, okay, the representation is actually an iceberg table under the hood, so you get the benefits of the rich metadata that iceberg tables provide to allow you to accelerate queries on that materialization. So the original table might be, let's say, a SQL Server table, and then you create a reflection on it. It's going to create that Apache Iceberg representation on your data lake, and then swap that out when queries go for that come in for that original table. Which one reduces the amount of work being put on your SQL Server in that situation, but 2, again, allows you to scan that data a lot faster because you're taking advantage of the Apache Iceberg indexing. 1, these reflections can be fine-tuned in the sense that you can not reflect every column. You can say, hey, I really only want to reflect these 2 columns because those are the columns that come up in most queries. Okay, generally most of my queries are only asking for these 2 columns and that's it. So in that case, I can say, hey, only materialize those 2 columns. I can set some partitioning and sorting logic for that reflection. And so in that case, for example, if I have a voters data that represents voters across the country, what I can do is I can sit there and say, hey, create a reflection that is partitioned by party. So then when queries come in that are, filtering based on party, okay, it might, go right in there. In this case, we have this view that's derived from that original voters table, voters green, okay, and basically it's aware of the partitioning of the partitioned reflection and realizes it can use that to probably accelerate this query, okay. So in this case, whether it's on the original voters table or a descendant view of that voters table, they can both benefit from the reflection if the Dremio determines that the query will be faster by using that reflection. Okay, and again, I can have multiple reflections on a single view or table, and again, and then that I'm not increasing the namespaces at all. So in that case, everyone just queries the same sort of maybe handful of namespaces instead of dozens of namespaces. So it makes it much easier to track for the analyst. They just query what makes sense to query, the voters table, and Dremio will figure out how to make that query fast based on the reflections that were constructed. And this is even easier nowadays because you have 2 things. You have incremental reflection refresh, which is really more about keeping your reflections nice and fresh, so that way they're always kind of matching the source data. But two, you also have the reflection recommender, which will actually monitor your query patterns. So instead of you having to figure out, hey, which reflections should I create, when should I create them, Dremio will recommend those for you and actually give you the SQL to create those reflections. So that way, in that case, you just every once in a while check in on the reflection recommender. It'll say, hey, based on the queries we've been noticing, you should probably create these reflections. So this way you're not creating reflections that don't benefit you, that can actually, not be helpful. And you only make sure that you have the reflections that are helpful, that are going to, one, increase your speed and overall increase the overall efficiency of your data platform, reducing your costs and not increasing your costs. Okay, so hopefully you guys enjoyed that. I'll see y'all later.